Here we discuss the solution of a problem from the section Linear Algebra. The problem is on quadratic forms. The problem was given in CSIR-UGC National Eligibility Test held on 26th November 2020. The question is from the section C, wherein each question carries 4.75 marks. The problem is a quadratic form Q of x comma y comma z over R, the set of real numbers, represents 0 non-trivially if there exists a triplet a comma b comma c belongs to R cube other than the 0 triplet such that Q of ABC is equal to 0. Which of the following quadratic forms Qxyz over R represents 0 non-trivially? We are given 4 quadratic forms, and we will consider one after the other and we'll decide which quadratic form over R represents 0 non-trivially. We have the given quadratic forms Q of x comma y comma z over R. This is our definition. A quadratic form Q of x comma y comma z over the set of real numbers represents 0 non-trivially if there exists a triad a comma b comma c belongs to R cube other than 0 comma 0 comma 0 such that Q of a comma b comma c is equal to 0. The first option, the quadratic form is Q of x comma y comma z is equal to xy plus z square. Now there exists a triad 1 minus 1 1. So 1 into minus 1 plus 1 square 1, it will be 0. So there exists a triad 1 comma minus 1 comma 1 belongs to R cube, which is obviously not a 0 triad, such that Q of 1 comma minus 1 comma 1 will be 1 into minus 1 plus 1 square, that is equal to 0. Therefore, by our definition, option 1 represents 0 non-trivially. Let us take the second option. Q of x comma y comma z is equal to x square plus 3y square minus 2z square. What is that we have considered? We have considered there exists root 2 comma 0 comma 1, which is a triad from R cube, which is not a 0 triad, such that root 2 square plus 3 times 0 square minus 2 times 1 is 0. Q of root 2 comma 0 comma 1 is equal to root 2 square plus 3 times 0 square minus 2 times 1 square, that will be 0. Therefore, the option 2 represents 0 non-trivially. Let's now consider the fourth quadratic form Q of x comma y comma z is equal to x square plus xy plus z square. So if I take x is 1 square plus 1 into minus 1, that will be 0. Z, you keep it as 0. That means you will have a triad 1 comma minus 1 comma 0 belongs to R cube, which is obviously not a 0 triad, which will satisfy this. So there exists 1 comma minus 1 comma 0 belongs to R cube, which is not a 0 triad, such that Q of 1 comma minus 1 comma 0 is equal to 1 square plus 1 into minus 1 plus 0 square is equal to 0. Therefore, option 4 represents 0 non-trivially. So the options 1 to 4 so far represents 0 non-trivially. Let us consider the third. q of x comma y comma z is equal to x square minus xy plus y square plus z square. We see that this quadratic form can be written as x minus half whole square, x minus half whole square, adjust the terms, 1/4 plus 1, that is 3/4 y square plus z square. So you can write x minus half whole square plus 3/4 y square plus z square. So I have written this quadratic form as the sums of the squares. The sums of the squares is greater than or equal to 0 always for all x, y, z, the triads belonging to R cube. Now we see this quadratic form will be 0 if and only if the triad xyz, x comma y comma z is the 0 triad 0 comma 0 comma 0. That we will see now. Q of x comma y comma z is equal to 0 if and only if is equal to 0, y is equal to 0, z is equal to 0. This is if and only if this happens. And this is if and only if x is equal to y is equal to z is equal to 0. That is if and only if the triad x comma y comma z is equal to the triad 0 comma 0 comma 0. That means q of x comma y comma z is 0 if and only if the x comma y comma z is equal to 0 comma 0 comma 0. So q of xyz is greater than 0 for all xyz belongs to R cube other than the 0 triad. So that therefore q of ABC is not equal to 0 for any ABC belongs to R cube other than the 0 vector. So therefore option 3 does not represent 0 non-trivially over R. Note, a quadratic form q of x comma y comma z over R does not represent 0 non-trivially if and only if q of x comma y comma z is positive definite. That's what exactly we have shown, that this q of x comma y comma z is greater than 0 for all x, y, z belongs to R cube other than the 0 vector. So that is positive definiteness only what we have shown. So our answer, final answer is options 1, 2, 4 represent 0 non-trivially, and this option 3 does not represent 0 non-trivially. Our answer is 1, 2, 4. So that is the discussion of the problem from linear algebra that has appeared in a national eligibility test. And the question is on quadratic forms. I hope that you have understood the solution. I wish you all the best. Thank you.